All right, guys, so we're finishing up the note sheet from yesterday, and we really don't have too much more to add to it. We finished this problem yesterday. Verify that f of x and g of x are inverses. So we went through this and showing that these are inverses. And to show that two functions are inverses of each other is showing that f of g of x is the same as g of f of x. And more specifically, that both of these equal x. Because if both f of g of x and g of f of x equal x, then they are inverses of each other. And part of the reason that this works, and the reason that we know they are inverses of each other, if they both equal x, is that, again, bring the two circles back out our domain and range, x and y, is that we're saying f of x, okay, f of x is taking the domain, the x values to y, and the inverse is taking it right back to where it started. So if f of x and g of x are indeed inverses, when we take the composite of it, we should get back where we started. So we'll look at this one here to start with, f of x and g of x. So f of x is 2x plus 4. G of x is x minus 4 divided by 2. Do we believe that these are going to be inverses? Yes. And the problem tells us actually that they are. Because it says verify that these are inverses. So it's essentially telling us that they are. We just have to show it. So we can start off with f of g of x. Now the first part is we're plugging x into g of x, which really just says that we're replacing g of x with its function, x minus 4 all over 2. Now at this point here, we're going to plug x minus 4 over 2 into every x in f of x, which tells us that we have 2 times the quantity, x minus 4 divided by 2, plus 4. Now we just need to simplify. So when we do the multiplication of 2, the 2 and 2 here will simplify, leaving us with x minus 4 plus 4, which is just x. Any questions on how we found f of g of x? We can do the same thing with g of f of x. So we can plug in f of x into this here, which is going to be 2x plus 4, to replace f of x. And again, just like with the previous one, we're going to plug 2x plus 4 into every x in f of x. Or sorry, every x in g of x, which would give us 2x plus 4 minus 4 all over 2. Well, we can drop the parentheses, which just gives us 2x plus 4 minus 4 over 2, while our plus 4 and minus 4 will simplify and out, leaving us with just 2x divided by 2, which is x. So we have indeed shown that f of g of x is equal to g of f of x, which is equal to x. We verified that the two are indeed inverses. Questions on any of this here? We feel comfortable with this? We can go on and do this one and the next one. We've only got 2 left, and then we are finished with this note sheet here. Now this one here, we're going to go on and do it. This one here is not too bad to find if they are inverses. Now this one tells us to determine, so there's a chance that it could or could not be inverses. So the first thing we need to look at is f of g of x. Well, g of x in our case is x minus 5. Now we're going to plug x minus 5 into every x in f of x, which tells us that we have x minus 5 plus 5. Which we can drop the parentheses, our negative 5 plus 5, simplify out, telling us that it is x. Now we can go the other way around, g of f of x. Now we can plug f of x, plug x into f of x, or just replace f of x with its function, which is x plus 5. Now this time we're going to plug x plus 5 into every x in g of x, which tells us that we have x plus 5 minus 5. Tells us that we have x plus 5 minus 5, which is x. So are these inverses? Yes, they are inverses because f of g of x is the same as g of f of x, and they are both x. Now, even if they both gave us, even if both composites, f of g of x and g of f of x, gave us the same thing, if they are not both equal to x, then they are not inverses. So even if both functions gave us 14x, it's not inverses. They need to be equal to x. Last one. This is the last one here. So we can start off, I normally start off with f of g of x. No real mathematical reasoning for it. I just picked this one to start with. Now the first thing we can do is plug x into g of x, or replace g of x with what it's equal to. So we have the cubed root of 2x. And at this point here, we're plugging the cubed root of 2x in for every x in f of x, which tells us that we have 8 parentheses cubed root of 2x to the third. So okay, this looks somewhat promising, because the cubed root and the third power will cancel, telling us that we have 8 times 2x. And 8 times 2x is 16x. Is that what we wanted? Can we say that this is going to give us that these two are inverses? No. At this point, we can say not inverses. We can already say it's not inverses. Because for them to be inverses, f of g of x has to be equal to g of f of x, and both of them have to equal x. They both have to equal x. Well, we already see that f of g of x is not equal to x. Doesn't matter what g of f of x is, because both of them are not going to equal x. If one of them doesn't equal x, doesn't matter what the other one does. These are not inverses. Now, I'm going to go on and find g of f of x. So we have g, f of x is 8x cubed. And if we plug this in, g of x will have the cubed root of 2 times 8x cubed. Now we can multiply these together. 2 times 8 is 16x to the third. Now, we can't necessarily take the cubed root of 16 as it is, because there's not a number multiplied 3 times by itself. That will give us 16. But 2 multiplied by itself 3 times will give us 8. So we can bring that 2 out. We can also bring the x out because we can take the cubed root of x to the third, but that does leave us with the cubed root of 2. Just remember back doing cubed roots with numbers that aren't perfect cubes or perfect nth powers, we have to do the factor tree. So for us here, for 16, we have 2 times 8, 2 times 4, 2 times 2. We have one group of 2's that can go out of the radical, but one has to stay behind, and we get this here. But the bigger thing is that these two are not the same. They're both not x, so they're still not inverses. Questions on this here? Any question over anything we've done so far? And I believe for this to be inverses, g of x would need to equal the cubed root of x over 2, if these were actually to be inverses. And if we wanted to, we could verify that through our composite functions, or 8x to the third, enter, clear that out, y equals, enter, math, 4x over 2, graph. So we have that mirror image across the line, because inverses will always mirror across the line y equals x. But this here was not asking for us to find the inverse, it was just asking us to check these. Now for most of all the ones that we'll do f of g of x, g of f of x, doing that to check them is not bad, it's not a terrible process. For some, especially for the pre-calculus class and above, it's sometimes easier to just find the inverse of one of the two functions and see if it matches the other to determine it, but either way works. Now, are there any questions on any of the problems we did today or yesterday? And I should have started off with this. Are there any homework questions? Homework's a worksheet.